As a granular activated carbon contactor treats water, we have a diagram here. The water flowing in to be treated has a concentration of the contaminant equal to C0 in it, and it is absorbed by the granular activated carbon. And naturally, the first carbon that it sees begins to the adsorption process, and eventually that portion of that carbon becomes exhausted. So the bed exhausts from the top down as we move through the bed. Thus, as you move down below if we were plot the concentration of our contaminant in the water below the portion of the bed that's already exhausted, we define the absorptive zone, and we see that the concentration of that contaminant in water decreases as we move down through the bed. And when we get to the bottom of where the concentration is at 0 or at the breakthrough concentration, which is what we call this minimum point here, our breakthrough concentration, then we've reached the bottom of the absorptive zone. And so we see that as we use the activated carbon contactor to remove our contaminant, this absorptive zone moves down through the bed as the activated carbon above becomes exhausted. When it reaches the bottom, when the breakthrough point reaches the bottom of the bed, the effluent from the contactor will reach the breakthrough point. We'll be at that breakthrough concentration. As you continue to operate the contactor, the bottom portion of the bed then will eventually become exhausted, and the effluent from the contactor will have the same concentration of contaminant as the influent. And as we move down through the bed, this absorptive zone concentration, you'll see, will rise according to that curve in the effluent of the contactor.